What is Math World, and welcome back. Today on Math we're going to talk about half angle formulas. Remember back from our double angle formula that we have cosine of 2 theta equals 2 cosine squared theta minus 1. And here Professor Axler asks us to find the exact expression for cosine of 15 degrees. Well, let's put on a critical thinking hats and do a little problem solving here and just kind of think about this for a second. We know that cosine of 15 degrees, hopefully we know that twice that angle size will give us obviously a cosine of 30 degrees. And hopefully we understand that also that if we call this angle here theta, then twice that angle size is obviously going to be 2 theta. So if this is cosine of theta, then this is obviously going to give me my cosine of 2 theta. And obviously we should be comfortable with being cosine, we should know the value of cosine of 30 degrees being, more importantly, square root of 3 over 2. But let's figure out how we can put this into our expression. So if we use a double angle formula, we can say that the cosine of 30 degrees is going to be equivalent to 2 times the cosine squared of 15 degrees minus 1, using a double angle formula. Well, like we said, we know this expression is square root of 3 over 2. That leaves us with the expression of 2 cosine squared of 15 degrees, the one we're trying to find, minus 1. And going through some simple math, we are left with the square root of 3 over 2 plus 1 equals 2 cosine squared of 15 degrees. Furthermore, we get this. And next, obviously, we need to divide both sides by 2. So we're left with the square root of 3 over 2 plus 1 quantity, all divided by 2 is equivalent to cosine squared of 15 degrees. And our last option, or our last operation, is to take the square root of both sides, which leaves me finally with the square root of 3 over 2 plus 1 all over 2 gives me the value of cosine of 15 degrees. And this is the exact value. This is the exact value. Now, let's go through some simplification and try to make it a little neater. And if we multiply internally inside this expression by a factor of 1, which is simply 2 over 2, we're left with the big square root of 3 plus 2 all over 4. And we can take the square root of 4 to make it pretty, so we get a square root of the square root of 3 plus 2 all over 2, and that is the exact value of cosine of 15 degrees. But the big concept here is using our double angle formula to help us find out the half angle formula. So ultimately, solving for the half angle, if we take the double angle formula, which we have here, and let's say we're going to substitute a value of theta is equivalent to, we're going to say theta over 2. So here this becomes nothing more than cosine of 2 times theta over 2. Substituting that angle in, and 2 cosine squared of theta over 2 minus 1. Well, this comes out to being obviously cosine of theta equaling 2 cosine squared theta over 2 minus 1. And we're trying to find that half angle formula, which is located there, so we're going to isolate that guy. So we got cosine plus 1 equaling 2 cosine squared of our half angle. And then dividing by 2, I'm left with cosine theta plus 1 divided by 2 equals cosine square theta over 2. And our last final operation is taking the square root of both sides, so I'm left with plus or minus the square root of cosine of theta plus 1 over 2 is equivalent to my half cosine of theta over 2, or my half angle. And that is my half angle formula for the cosine. So that essentially is my half angle formula for cosine. And the plus or minus also, refers to what quadrant. You're going to have to figure out what quadrant we're in. Obviously, cosine is positive in the first and fourth quadrants, and negative in the second and third quadrants. And to find the half angle formula for sine, I'm going to use my double angle of cosine formula, but the one that involves a sine function in there, so I can solve this. And again, I'm going to use the same idea as I've done before, and I'm going to substitute in for angle theta of theta over 2 equals 1 minus 2 sine squared of theta over 2. And again, that comes out to be nothing more than cosine of theta is 1 minus 2 sine squared of theta over 2. substituting or solving for sine squared of theta, I'm left with cosine squared of theta minus 1 divided by a negative 2 is equivalent to sine squared of theta over 2. And then my last step is taking the plus or minus the square root, so plus or minus the square root of cosine theta minus 1 over negative 2 is equal to sine of theta over 2. And if I want to make this positive inside here, I'm left with obviously sine of half theta or theta over 2 is equivalent to plus or minus the square root of 1 minus cosine theta over 2, and that is my half angle formula for sine. Now in this example, you're asked to find the exact expression for sine of pi over 8. Again, the key word exact, so I can't use any decimal approximations. So I need to find what I'm looking for is sine of pi over 8. But I can also know that this is half of, or at least I should say, pi over 8, we should be comfortable is basically half of pi over 4. So that can obviously use my half angle formula, since I know what the value of pi, or I should know what the value of not only sine of pi over 4 is, but obviously cosine of pi over 4 is. So if I'm using my expression here, I know that that's going to be plus or minus the 1 minus cosine of the half angle, which in this case is pi over 4, all over 2. Again, this is nothing more than my half angle formula for sine, and that obviously gives me 1 minus the square root of 2 over 2 all over 2 under the root. And going through that equation and simplifying my math, obviously I gotta make that 2 over 2 and all that good stuff, so that ends up coming out to being the square root of 2 minus the square root of 2 after combining light fractions all over 4 when I multiply both sides or up and down by 2, and that also equates to being nothing more than 2 minus the square root of 2 all over 2. So that is my exact expression, and again, plus or minus, in this case I'm going to be using the positive because I know that pi over 8 is in quadrant 1, which is where sine has a positive value in quadrant 1. So that is my answer, the exact expression for sine of pi over 8. And just to note, we should always be comfortable with the tangent of theta is nothing more than sine of theta over cosine of theta. So if I needed to find the tangent of the double angle of theta, then I'm simply going to solve basically sine of 2 theta over the cosine of 2 theta and go through an expression for that. And after I do that for the double angle, my double angle tangent comes out to be nothing more than tangent of theta, 2 times the tangent of theta over 1 minus tangent squared of theta. And likewise, for the half angle of theta, I'm going to use the same idea that simply tangent is nothing more than sine over cosine. So I have actually multiple possibilities for this. One possibility is 1 minus cosine theta all over sine of theta, and the other possibility, if I use a different substitution method, would be sine of theta all over 1 plus cosine of theta. So again, whenever in doubt, tangent of theta is nothing more than sine of theta over cosine of theta, and you go through and solve all those. Hope these have helped you, and remember, you can always check back to ISOmath for all your math needs. See you soon.